polar coordinate system. We are very familiar with the rectangular coordinate system, which is the normal XY method for locating points in the plane. For example, if I had some point right here and I wanted to describe to somebody its location, I would say, well, start here at the origin, otherwise known as 0, 0, and then walk to the right or left a distance of x units as necessary. From there, walk up or down a distance of y units as necessary. And as you know, we use those two distances to name this particular point. This becomes the point x comma y in the rectangular coordinate system. Another way to think of this, if someone was standing here and you wanted them to end up here, you could tell them, oh, just walk toward the east x units and then turn toward the north and travel y units, and you'll be at the desired destination. So we work with the rectangular coordinate system all the time, but it is not the only way to locate a point in the plane. Let's consider that same point and now look at what is referred to as the polar coordinate system. How does this system work? Well, once again, I'm going to start here at the origin. But the polar system is not based on moving horizontally or vertically, left, right, up, down. The polar system says, look, if you want to start here and end up at this other point, just rotate from the positive x-axis a certain angle, whatever angle you need to be facing the point you're trying to get to. I'll call that angle theta. And then walk directly toward it a certain number of steps until you arrive. We'll say it's r steps. Well, the name for this point in the polar coordinate system is r comma theta. R, the distance from the origin to the point, the direct distance. Theta, the angle that I had to rotate from the positive x-axis. Again, you can picture my person standing there. This sounds like an even more direct way of getting from point A to point B. Stand here, instead of moving east and north and all this stuff, rotate your body so that you are facing the point in question, and then just walk straight there. That's the polar coordinate system. Now, here are a few comments. First, some notes about theta. If theta is positive, then you'll be rotating counterclockwise. If theta is negative, then we will rotate around clockwise. In other words, the angle works exactly like what we're used to. Let's demo that a little bit. Suppose I had this point right here, 3 spaces above the origin, right there on the y-axis, and I was trying to communicate to someone standing at the origin how to get to that point. In polar coordinates, the default is that the person starts facing the positive x-axis. Imagine somebody standing there looking in that direction. Well, how would you tell them to both rotate and walk so that they could get from where they are to where we want them to end up? One of the things you quickly realize is that there's more than one set of instructions that will work. In other words, points have multiple polar coordinate names, and that does take some getting used to. The simplest way that I could tell this person what to do would be rotate around 90 degrees in a counterclockwise direction. So now the person is facing the positive y-axis, and then step forward 1, 2, 3 spaces. This would be the point 3. Remember, r comes first, comma, and I'll use radians, pi over 2, or 90 degrees if I was working in degrees. But that's not the only way that I could have told that person to get there. Let's go back to this person facing the positive x-axis. I could have had them rotate around clockwise. Now, it would take a little bit more rotation. It would take 270 degrees around that way, and then have them walk 3 steps forward. and they'd end up at the same spot. This would be the point 3 comma negative, I'm going to use a negative because I rotated around clockwise, 3 pi over 2 would be 270 degrees, right? 3 comma negative 3 pi over 2. So that is another polar name for the same point. What about the r? Well, this is interesting as well. If r is a positive number, which is all we've addressed so far, that means walk forward. That is, face the direction that theta tells you to face and walk forward that many steps. However, if r is a negative number, the way the polar system works is this means walk backward. Well, that means I have even more possible ways of getting to my final destination here. Remember, I start at the origin. I'm facing the positive x-axis. I'm going to rotate around some amount, and now I know I have the option of walking either forward or backward. So, one way that I could get to that spot up there, this spot right here that I want, is I could rotate around clockwise 90 degrees. I'd now be facing this direction, and then standing there while I'm facing downward, I would actually walk backwards 1, 2, 3 spaces, meaning another polar coordinate name for this point would be -3 because I walked backwards, and negative pi over 2 because I rotated around 90 degrees, pi over 2 radians, in a clockwise direction. Again, the key is to think about where your eyes are looking. You start looking in this direction. You're going to rotate around a certain amount. That's where your eyes are looking now. And then the sign of R tells you whether you will walk forward or backward from there. Thanks for watching.